So we have now a keynote of diplom engineer Monika Denner of the, as I said, of the Austrian Umweltbundesamt, the environmental agency of the Ministry for Climate Protection, and she's gonna speak to us about quality assurance systems for solid recovered fuels in Austria, status quo and development. And Monika Denner, as Renato also hinted, is also Austrian delegate for solid recovered fuels in the ISO working group, and has participated in several international validation projects and for recycling index for co-processing, for example. So Monika, I see your presentation, super, and it's your microphone.
Thank you. Welcome to everybody, and thank you, Renato, for this introduction, and congratulations to this position paper. As you said, Renato, quality assurance system for solid recovered fuels is a very, very basic and main part to enable solid recovered fuels to be used for co-processing, and to also have the acceptance by public authorities and other market players. So let's start with the importance of quality concepts. As you all know, and in Austria, we have the waste incineration ordinance for co-incineration of solid recovered fuels in cement industry. We have limit values that are laid down in the regulation. And normally, of course, compliance with limit values are checked on the basis of qualified samples and measurement results. And former ordinances only had tables with values, for example, heavy metals and so on inside, and no comprehensive concept. What does this mean? How to derive these values, how to sample, so how to have the compliance with a certain limit values done and proved. And to recap, so to enable solid recovered fuels that have solid recovered fuels, as you all know, are a subgroup of refused derived fuels and fulfill certain quality demands. And so quality assurance has already to start with the beginning of the production of solid recovered fuels to reach the quality. And of course, you also need a quality assurance system in course of data generation and evaluation based on samples. So how did we solve this in Austria? As you all heard, Austria last year, 2022, 75%, and in some facilities in Austria, even up to 95% rate, where fossil primary energy can be substituted by solid recovered fuels. So of course, it's of main importance to have a quality assurance system to guarantee the characteristics of a waste fuel produced. And we also have, as you all know, variations concerning waste streams and concerning solid recovered fuels. So this has also to be addressed in terms of compliance testing, comparison with limit values. Then we have in Austria limit values for contents of pollutants in substitute fuels. And if you look on the list, this is not the complete periodic system of elements, but specific key elements that have been decided to use as driver, as key elements to decide on the quality, if the quality is okay to be used as solid recovered fuels for co-processing, for example, or even if you can talk about an end of waste status. And it is very valuable, this standardization work in ISO TC 300 or also in the former SANE TC 343, because at the moment we have a comprehensive set of standards and specifications, starting with classes for solid recovered fuels, and sampling, sample preparation, and also determination methods. So description of analytical procedures. And all these standards are referred to in the Austrian legislation. So in the Austrian Waste Incineration Ordinance, we have 2 annexes, especially dealing with us SRF. So Annex 8 is for solid recovered fuels that are used in co-incineration plants. And Annex 9 describes the quality criteria and the way how to get an end of waste criteria for which of the streams of SRF to enable product status quo. So here you have a overview of some relevant standards. So we have the sampling standard. It's an European and international EN ISO standard. We have also a comprehensive standard for the sample preparation, also very important because, of course, solid recovered fuels are heterogeneous materials. And we have the Waste Incineration Ordinance. In Austria, it's the legislation number 389, 2002 in the current version. And an amendment is already in preparation, and it is planned in 2024 to have a new amendment of the Austrian Waste Incineration Ordinance. And what I'm talking about later on, I will show you what is coming next, what will be part of the amendment of the Waste Incineration Ordinance. So, and to go a step back, all this work, there has been a preliminary work, and all this work was basically standardized on standards for waste. So we have a framework how to make sampling plans for waste. It's the European standard 14899. And this standard is also accompanied by a 5 series SEAN TR 15310. And what do you think about how or why do we need certain standards for solid recovered fuels if we already have waste standards? It's because solid recovered fuels have their specific characteristics. So they are heterogeneous, but also waste can be very heterogeneous, as you know, but SRF can have high particle sizes up to 300 millimeters, or it depends when you want to put them in primary firing or secondary firing in the co-incineration plants. And you have mainly flat fluffs, flat particles, and this is all technical that has to be addressed in calculations where you derive scientifically based minimum mass size, minimum increment size, and even where you have to calculate the number of samples you have to take in order to have a basic and very sound decision base, namely the samples and the values, and that are used to decide if you have a good quality of SRF to be used in the co-incineration plant. And to enable uniform interpretation, it is very necessary to have these relevant key elements also addressed in legislation. So just to have a list with limit values is not enough. And here you can find on this slide an overview of key elements that are questions you have to answer in course of planning a plan to make a sampling plan, for example, solid recovered fuels. So the objective could be to derive the quality of a waste stream of solid recovered fuels. And so maybe you have an yearly production of more than 50,000 tons or even more. So you have to know what is the lot or the lot size that you have to base your decisions on. So where you have to distribute the samples, and this is defined by the European standard. We have here a maximum lot size of 1,500 tons. The second point, sampling frequency. You won't find the sampling frequency in the standard. So the legislation has to address how often do you have to analyze, how often do you have to sample your solid recovered fuels and to compare this quality with limit values. So you, of course, have to decide upon sampling procedure, so how to take the samples. You have to decide upon number of increments, so how much increments can be used or shall be used at least to be made up in a combined sample. And you base decisions on a combined sample. And in this international standard, it is defined with at least 24 increments if you sample a maximum lot size of 1,500 tons. So finally, you plan your minimum sample mass, because it is easily to understand if you just would have unmotivated samplers and they go out and take some samples anywhere, maybe only a few grams or half a kilogram, and indeed you have solid recovered fuels with 300 millimeters particle size, very flat. So it's easily to understand that maybe the quality of these computed values is not achieved, and it is not worth to have a sample like this. So it's all about the quality of your SRF, and to derive this proper quality, it's all about quality in sampling and sample preparation. And finally, this procedure has to be documented in sampling protocols. And on this slide, I can show you an output of Annex 8 of the Austrian incineration ordinance for waste. So how is the thing solved in Austria? We have a sampling regulation for waste streams higher than 40,000 tons per year to address the big waste streams for solid recovered fuels. And we also have a specific sampling regulations for on-off or for smaller waste streams. And what is very specific in Austria, we also have sampling regulations for liquid waste in our waste incineration ordinance. And we also define here some standards how to get along. So in case of the sampling regulation for waste streams, big waste streams, we defined in Austria when we start and we don't know anything about the solid recovered fuel, the lot size is the quantity of waste that is produced in 1 month. And to get the samples, we defined a sub-lot size that would be the average daily production quantity. And in the new amendment, we also have the alternative to have the lot size of 1,500 tons and to sample at least 2 lots per month, and to have the decision if the quality is complying with the limit values. And concerning testing of the quality, the compliance with limit values must be evaluated for each of the waste separately in accordance with origin and waste type. So for each stream of solidly covered fuel, you have to derive the quality in separate sampling strategies. And how do we do the sampling for waste streams? So in the first year, the first lot, we have to do a thorough investigation based on 10 combined samples that are prepared and analyzed. So within 1 month, that means you select 10 days, distribute them throughout the monthly production, and finally you have 10 samples and 10 results. And you calculate the median and the 80th percentile of these 10 samples, and then you can compare it to the limit values. The median and the 80th percentile are the statistical parameters how to derive compliance with limit values. Why did we take this? As you all know, solid recovered fuels are heterogeneous. And so you won't wonder that we don't have limit values for copper in the list of the waste incineration ordinance. Because copper wire can be very badly distributed and you have some nugget effects. But concerning the environment element like mercury, it is very important to have the median and 80th percentile as calculation. And because you are not allowed to eliminate outliers from your testing. And so Austria decided it is very basic to not allow to eliminate outliers and to have the whole set of data for compliance testing. And so it is very necessary to have statistical sound parameters like median and 80th percentile, and all limit compliance testing is done with the last 10 values you have for the lot. And so it is very stringent in Austria, because if you have 10 lots already tested and you have the 11th lot, you check if the last 10 lots finally comply with the limit values. And so you can be safe being compared to have a median or 80th percentile calculated over 1,000 values, for example, that you are in quality control. So starting with the first lot, you have a thorough investigation, and starting from the second lot, you take 2 combined samples per month, because you already have the knowledge from a first lot. And finally, you have 2 combined samples, each representing 1,500 tons. And the same applies for sampling regulations for smaller waste streams. Here we have only lot size 1,500 tons. And we divide the first lot of 1,500 tons into sublots of 150 tons. And according to the waste incineration ordinance, sublots number 1, so the first 150 tons, sublot number 3, 4, 7, and 9 have to be selected for analysis. So let's say for sampling analysis and for calculation of starting with a average value. If you only have one lot, of course you have one value. when you have 2 values, 3 values, and you test compliance with the limit values after each lot. And beginning with lot 2, so the second 1,500 tons of production of SRF, you do one combined sample per 1,500 tons, analyze it, and finally you calculate again median and 80th percentile, and the knowledge and the database will grow and grow if you have a waste stream, and if you have a on-off, you just calculate all data. You take all data and calculate median and 80th percentile and compare this with the limit values. Here you have the list of limit values. On the left side, we have specific key elements, heavy metals, and also mercury and antimony. This is a set for limit values for solid recovered fuels that are used for co-incineration in cement plants. And on the right slide, you see limit values specific for other co-incineration plants. So we have here antimony, arsenic, lead, cadmium, chromium, copper, nickel, and mercury. And as you can see from the limit values, they have a unit milligrams per megajoule. And now I go more into detail into the Annex 9 of our Waste Incineration Ordinance. Here is a statement for end of waste for SRF products. And also we describe sampling regulations for products here. So the lot size for products, or maybe solid recovered fuels, they should be tested to if they fulfill the quality criteria for end of waste status, is a lot size of 1,500 tons and a sub-lot size of 150 tons. And also here we have a detailed investigation in the first lot, and finally a routine investigation starting with the second lot. So when you have the first lot of 1,500 tons, you do testing finally after you have 150 tons. So this is sub lot number 1, and you take your samples, 10 samples, and test one combined sample from sub-lot number 1. And so you go on. So the third sub-lot of 150 tons is tested again, and you have some calculation. The fifth sub-lot, 7th and 9th. And you only have 2 combined samples per each of the sub-lot. So overall, you have 10 samples and 10 results as minimum to derive the quality of a solid recovered fuel that might be a product, starting with the first lot. And if all fits, it can be finally investigated with a knowledge of the first lot by 2 combined samples, each representing 1,500 tons. And how do you calculate and compare with limit values? Of course, after sub-lot number 1, you have the first 150 tons, you can do some calculation, and so on and so on. And also here, it's the same procedure. You only calculate the last 10 results, standing for the last 10 lots. And you have a good quality. And if you have the 11th lot, you also take the last 10. Also here, it is not allowed to do any outlier elimination. So you have to provide all data sets you have to derive the quality and to have your comprehensive investigation sheet for this end of waste status. And here you can find the limit values on the left side for waste fuel products from waste wood. Waste wood here means it's the waste of code number group 17 in accordance with a list of waste ordinance. And on the right side, you can find limit values for the end of waste status for other waste fuel products, maybe plastic-based waste fuel products. And if you have a detailed look on the key parameters here, for waste wood, we have arsenic, lead, cadmium, chromium, mercury, and also zinc, chlorine, fluorine, and the sum of 16 PAHs. And on the right side, we have the specific parameters, let's say antimony, as it is a very valuable element to address plastics waste, arsenic, lead, cadmium, chromium, nickel and mercury, and also sulfur and chlorine. And the basis for this set of key parameters was for waste wood the comparison to normal wood. So we have a sound statistical database for here. And the limit values are in milligram per kilogram dry mass. So wood was calculated, and these limit values are based on untreated wood samples. On the left side, the limit values in milligram per megajoule were derived by comparison with the quality of hard coal. And so these key parameters were defined. We have it now in the waste incineration ordinance, and it was also notified by the European Commission that Austria has this end of waste criteria for some quality of solid recovered fuels. And talking about Austria, in Austria, at the moment, we have around 150 products according to this end of waste criteria. 95% of these products are wood-based products, and so around 5%, the rest is based on plastics waste. So 300,000 tons per year with the end of waste criteria that have reached product status. And what is also very important for the end of waste criteria for solid recovered fuels, according to the Austrian ordinance, it is preliminary that the work is done in accordance with the waste incineration ordinance. And as I could show you, we have a compliance with limit values for products. And also we have the plan how to take the samples, when to take samples, and what is a lot size and how many samples the decisions are based on. And the end of waste status has also the intended use. And this is that you have also to notify to the Ministry of Environment where these solid recovered fuels products, in which facilities they should or might be used. And fulfilling the instructions for use, here it is also mandatory that waste fuel products may be incinerated only in plants with a rated thermal output more than 100 kilowatt that comply with a limit value for dust in the amount of 20 milligrams per cubic meter on a half-hourly value basis. This is also to be taken into account when speaking about end of waste in Austria. So to sum up, as you all heard, the standardization work is very, very valuable Austria is actively involved in the ISO TC 300, solid recovered fuels. We are in the technical committee 300. We are in working group 3. This was a working group that provided the standards for sampling and sample preparation. We are also in working group 4 and working group 5. As Renato has told you, the active projects now are the solid recovered fuel standards that should be an ISO EN standard for the determination of the recycling index for co-processing. And also I'm the project leader for the solid recovered fuel standards to have the methods for the determination of the content of elements. Of course, here it's very important that we have our decisions based on total content of elements. As in co-incineration, the ash is, for example, in the clinker and keeps in the product. And so it is also here relevant to have the proper standards for the analytical point of view. And what we did together with the Montana University of Leoben, we provided real samples from 4 waste streams of Austria, namely paper, fiber sludge, sewage sludge samples, waste wood samples, and a high calorific fraction from non-hazardous residual waste and ash fractions. And we did a thorough investigation in course of validation of both standards. Here you have the report. It's available in the internet. And this was a very valuable work. And it was necessary to check if both standards are fit for purpose. So if all laboratories come to good values, if we derive the recycling index, if the standard is already, and finally we can say, yes, both standards are ready to become an ISO EN standard, and both standards have a performance annex B inside showing all data that we derived in this validation project. This validation project was financed by the Ministry for Environment of Austria. So this was also very important because we couldn't do that without any financing. And now we have an outlook. Maybe here are also some solid recovered fuels producers. So there are upcoming standards from the ISO TC 300, determination of bulk density, but also the ash melting behavior is planned. And last but not least, maybe most important, Germany plans to use their basis of the German standard 54390 and use this test method for continuous process analysis by near-infrared spectroscopy for the indirect determination of fuel characterizing parameters. And so we would have with this standard a possibility for online analysis by NIS for total chlorine content, for water content, and the heating value. And this would be very valuable for the SRF producers to guarantee the quality. So on the last slide, you can have a look later on. You have an overview of relevant standards and also the link to our validation report. So thanks for your interest. And
yeah, thank you very much, Monika, for this very interesting presentation. And we have a quick question by Robert Uweck. Do you want to pose the question?
Yes. I was thinking on that the question would be dedicated to Renato or Monika, but I think for both of them, or they can answer it. That the question is that when do you see feasible and these standards for the SRF, which classifying as a product, to be used in the EU as a daily practice or a daily routine? because, for example, in Czech Republic, there is a lot a short and long history of this classifying the SRF for a product end of waste, and the question, because if it is classified as an end of waste criteria and material which is fulfilling the quality requirements, then when it will be possible to use it as without notification process for export import of the waste between the countries, because currently the practice is that some customers are stating that material is a product, but if the receiving country has not applying the standard, it's gives nothing benefit for the exporting country. So the question, yeah,
thanks for the question. And maybe we have to point out that it is a difference between the classification system according to the ISO EN 21640 and, of course, the legal requirements in the member states. And so this is a basic, the standardization and classification standard, but it is also needed to have end of waste criteria by legislation, as we have in Austria. And so if we want to import solid recovered fuels to Austria with an end of waste status quo, of course you would have to fulfill the Austrian waste incineration ordinance, but you can do it easily because all the work that we did and described in the Annex 9 and based on samples, the sampling standards and everything is available as international European standards. And that should make the work easier for you.
Okay, thank you.
Super. We have Ed Verhamme with the question, and then Geert. Ed, you need to unmute yourself. Can you, if you want to pose it yourself? Yeah.
Yeah, I was wondering that I was missing bromide in all the analysis. And as we know, in some plastics, we still have bromide containing flame retardants. And that could be an issue when you co-process or incinerate that particular waste with that bromide, with bromide containing. So
yes. Thanks, Ed Verhamme, for this comment. You're completely right. Bromine can be an issue. But in Austria, we decided to have only key elements, and sometimes elements correlate with each other. So we have cadmium, we have antimony, and we have also chlorine. And so based on these parameters, you see if it is it could reach the end of waste status or not. That's what I wanted to express when I said we don't have the whole set of periodic elements. There would be a lot more knowledge base, but we wanted to have some key limit values. And until now, it seems to be a sound key parameter selection we have in Austria.
okay, thank you for the question, but I still don't understand if you look at chlorine, why you don't look at bromide, but it is what it is. Thank you for your answer.
Thank you. Geert?
Thank you, Tudor. I'd like to come back to the question about SRF and end of waste in Europe. By the way, I forgot to introduce myself properly last time. I'm Geert Cuperus, Secretary General of ERFO, European Recovered Fuel Organization. So we represent the producers of SRF. At the European level, the European Commission is looking into new regulations for end of waste, but unfortunately, SRF is not included in this list. So the first substances they will look into are plastics, various types of plastics. Indeed, if there is a need for end of waste for SRF in Europe, then yeah, we should give pressure to the commission to also look into that. But as I said, SRF at the moment is not very high on the list of the commission to develop a regulation for.
Yeah. Monika, do you want to comment on this, or?
Yeah, I just can speak about Austria, and I don't know, it was before 2020 when the Ministry for Environment notified this end of waste criteria we have in Austria for solid recovered fuels. And so this is a way we go in Austria, and it would make sense if others follow, but provided the quality of solid recovered fuels.
Yeah, super. Thank you very much.